Welcome to all participants. Am I audible? Hello? Am I audible to you?
Yes,
sir.
You are audible. You are audible to us. Thank you.
Yeah, okay, sir. This year, that is, District Science Center Gulbarga was started in 1984 on 6th January. Today is the 37th anniversary of the Science Center. In this connection, 3 days event, online events. In the Science Center, there was only one exhibition hall. Now there are 4 exhibition hall on fun, mathematics and electronics. And we have a 3D theater, planetarium, dinosaur park, science park, and also mobile science exhibition, and good telescope for sky observation. So with these facilities, Science Center is attracting large number of visitors to the Science Center. The COVID, we have organized various online events for the children, teachers, and also professors. Today, we have organized a special webinar on in space achievements and challenges. Dr. B.R. Guruprasad. He is retired public relation executive, scientist, and science communicator from the ISRO. Dr. Guruprasad has worked in the Indian Space Research Organization for about 37 years. Super animated in May 2020 as scientist special grade and associate director, Office of the Media and Public Relations, ISRO headquarters, Bangalore. Satellite mission plan and operations and over 25 Indian satellite missions at ISRO and now called as EVA. He has worked at German Space Agency and at NASA. He has invited to Japan in 2008 by Japanese Space Exploration Agency as a member of the panel on space education for young people and invited to France in 2010 for public related presentation. He advocated in the subject principles of flight. He wrote more than 500 articles on newspapers and for newsletters. He wrote on astronomy and space, English and Kannada, and contributed to many encyclopedias and compendiums. He has broadcasted 100 variety of science programs, including live phone program, EIR, IGNO, TV channels. He has delivered more than 500 years on various science in educational and public service institutions and teachers orientation program, and made many TV documentaries on space and astronomy in English and Kannada. Conducted many water rocket making workshop and launched international level and conducted more than 150 quiz programs in many parts of India and in radio TV. In space and astronomy, taught the teachers of Karnataka through satellite as part of Karnataka DACRT SATCOM program, interacted with the students in different parts of India simultaneously through webinars and podcasts. He has visited Australia, Dubai, France, Germany, Greece, Hong Kong, Japan, Qatar, Singapore, South Korea, Taiwan, Thailand, and United States. With this brief introduction, I would like to welcome today's speaker, Dr. B.R. Guruprasad.
Thank you. Thank you very much. I hope I'm audible properly because Mr. Lakshmi Narayana, kindly note that your the talk was breaking, in the sense voice was breaking. And now, am I audible correctly?
Yeah, you're audible. Your voice is, we can hear it properly. Thank you.
Fine. Thanks a lot, sir. Okay, good afternoon to all of you. And thanks for inviting me to this webinar. I personally thank Mr. Lakshmi Narayana, who heads the District Science Center at Gulbarga. And today, in this webinar, I'm going to speak to you people on India in space, achievements and challenges. So the story of India in space, one, okay, the thing is, India has achieved many things, okay, in the domain of space, and it is a major space-faring nation today. Though I'll be speaking to you people today on the Indian space program, let me make clear that I'm not a spokesman for ISRO or anything today. I superannuated in May, so I'm a science writer and broadcaster, okay? So what you will hear today is from a very passionate science communicator, that is a writer and broadcaster who is very much interested in space, especially the beneficial aspects of space. Over the past 4 decades, almost, since almost I was a kid, that is as a teenager, I have been writing about space and astronomy, both in Kannada and English. Okay, and I was very fortunate to work for the Indian space program for 37 years. Half the time I worked at ISRO Satellite Center, now which is renamed as U.R. Rao Satellite Center, okay, as a satellite scientist. And that was a very exciting work indeed. Then another 18 to 19 years, I worked in the public relations wing of the ISRO headquarters, first as public relations officer of ISRO. Then from 2018 onwards, I worked for 2 years as associate director PR. Okay, now anyway, all said and done. So I'm very passionate about space and astronomy, and I'll take you on a journey which reveals to you the exciting way in which India began its journey in space, okay, and it evolved over a period of 5 decades, and what are all the things which it has achieved. I'm not going to talk to you guys only on India has done this, India has done that, and such things, because the thing is, I have to tell you about the science and the engineering aspect behind it, but I don't want to bore you with too much of details and equations and such things. Suffice it to say that I'm going to speak to you people about the fundamentals, fundas. Okay, with this brief introduction, let me talk to you. Let me begin my presentation, okay, on the Indian space program, and I'm going to present. So in this, kindly bear with me. Okay, I hope it is visible. Is it visible to you now?
Yes, sir, it is visible.
Thanks a lot. Okay, India in space, achievements and challenges. Once again, I told you about it. Slide without wasting much time. Kindly reserve your questions till the end, and you can ask me as many questions as possible. I'll be much obliged to answer them, whatever I know. Today, as I told you, India is one of the major spacefaring nations. That is a country which has got enough capability, sufficient
Okay, it is
capability.
audible.
Yeah. India has
But your
enough.
PowerPoint has not come, sir.
It has come, I was told. Is it?
Yes, we can see the PowerPoint.
Yeah. Yeah. Now? Hello?
Yes, sir. Yeah, launching of the satellite kind of the stuff.
Yeah.
Showing at
5,
the
6
right hand
pictures
side.
are there. Yeah. Correct. That is the thing. Okay. Now, India today has the capability to design, develop, build, test, and launch, more importantly, launch satellites, as well as to manage them in orbit. At the same time, it has the capability to utilize them for various national developmental tasks. Okay, in the upper left of the picture, you see a satellite being used for nationwide communications purpose. Okay, and here is a picture showing the weather, image of the part of the Earth containing India. This is a weather picture. So satellites are being used for telecommunications and TV broadcasting, and satellites are being used for weather forecasting, resource management. I'll show you. Besides this, India has sent 2 unmanned spacecraft or robotic spacecraft towards the moon and Mars. Actually, 3. 2 of them have been sent towards the moon, and 1 is sent towards Mars. More importantly than anything else, India has the capability to launch satellites and robotic spacecraft into orbit. Not many countries, at least a few of them, have the capability to build satellites and to utilize satellites, test satellites, but they don't have the capability to launch satellites. But India is one of the 6 countries which have the capability to launch large satellites. There are countries which have launched very small satellites. Okay, India is one of the 6 countries which have the capability to launch large satellites into orbit. Now, this is the launch of an Earth observation satellite. That is a satellite which is launched for taking pictures of the Earth's surface, crystal clear pictures of the Earth's surface, for many things, for example, for map making, for agriculture, and many other things. I would like to emphasize here that this rocket was launched on November 7th, 2020, okay, about 2 months back. You know that the entire world has been devastated by the effects of COVID-19, and despite that, for quite some time, the launches had been stopped from India, and November 7th, it was resumed. And in the next slide, I will show you a clipping, okay, of this launch. See, you see this. It's available on the ISRO website. This is PSLV, India. See, you see that 15-story high rocket lifting off. See, it's going up, carrying 10 satellites actually. One is our satellite, Earth observation satellite. The other are from abroad. All 10 were launched into proper orbits without any hitch. See, this is the real picture. See, this is the way the heat shield of the rocket is being separated. Okay, you saw that. This is the way a satellite separates from the last stage of the rocket in space. Okay, you can see the satellite going away from the rocket. The camera is in the rocket actually. You can see you see the satellites from many other countries. 9 satellites from other countries are being thrown out like small urchins throw stones towards some mangoes in an orchard kind of thing. That is the way it is, but it is not that simple. See, so all the 10 satellites were put into proper orbit, and that shows India's capability in the domain of space. It's not easy to launch a satellite into space. It is not like driving a car kind of thing or producing even an aeroplane, not like that, because space is a totally different thing. So the thing is, this is okay. All of us have to be proud about this. And okay, you see the next slide. In this slide, you are seeing the picture of PSLV again.
Whether
this was
able to see the screen, your presentation, just check. Whether others are able to see the presentation, just check.
It is visible, sir.
Mr. Lakshminarayana, we could
No.
see that one. Everything is going proper.
Yeah, it is going on. It is right.
So I would request you not to interrupt me. The thing is, if it is very serious, because as soon as I heard from one gentleman that everything is coming properly, then only progress.
Yeah, it's going on. Yeah, thank you.
Okay. Yeah. The previous launch, whatever I showed you, the clipping, one more time PSLV has been launched on December 17th. This time it carried a communication satellite. Last time it was an Earth observation satellite along with 9 satellites from other countries. Totally 10 satellites is launched. This time it launched a communication satellite. See the versatility of PSLV. It is the pride of India today. It has launched not only dozens of Indian satellites, it has launched 328 foreign satellites. 300 satellites, believe. See, many of our social science textbooks says, what are all the exports of India? They say that handicrafts, okay, spices, cotton textiles, okay, and many other things. But software nowadays everybody knows, but at the same time, India is providing sophisticated space services like satellite launching. Many people don't know this. I think these textbooks need to be updated, in fact. Now, let us see what is a satellite. Okay, satellite was a word which was being used to actually denote an object or a heavenly body which was going around a planet. Okay, Earth has got only one natural satellite, which is our moon, which is being shown in this picture, because moon is a natural satellite of the Earth. It occurs naturally. Nobody has launched it. No human being has launched it into orbit. Okay, so Earth has got one moon, Mars has got 2, Jupiter has got more than 60, Saturn also, in fact, more than that. Saturn has maximum number of satellites like that. Now, for nearly 4 billion years, moon was the only body, as we know, which circled, which orbited, or which went around the Earth. But on October 4th, 1957, a hollow sphere was launched on top of a rocket from the former Soviet Union, and that was the first artificial satellite of the Earth. That is an object which was made to circle the Earth artificially, in the sense using the technological means available to the human beings. When Sputnik 1, which is shown in this animation, went to space and started circling the Earth, it became a tiny rival to the moon. And that was the day, October 4th, 1957, when space age was born. Many people did not have any idea, even scientists in the developed countries did not have any idea as to what space can be used for. In fact, what is the use of satellites? Some people had some ideas, but nobody had tested. But here was this great visionary by name Dr. Vikram Sarabhai. So he said, let India have a space program, he said. And he was the person who headed it. He's the father of the Indian space program, the architect of the Indian space program. But many people said, India can't even build a bullock cart. How can it build satellites, rockets, and all those things? After all, for what purpose? Okay, is it only for PR purpose? Okay, it is a showpiece kind of thing. But Sarabhai said, no, actually. That's why I said there are some who question the relevance of space activities in a developing nation. To us, there is no ambiguity of purpose. We do not have the fantasy of competing with developed nations in the exploration of the moon, the planets, or the manned spacecraft. But you kindly see this. But we are convinced that if we are to play a meaningful role nationally and in the committee of the nations, then we should be second to none in the application of advanced technologies to the real problems of man and society. Many individuals in our country, okay, who are deprived of the good lifestyle, the society as such, okay, there are many problems to it. Such problems can be solved and we can leapfrog and develop very quickly, and we can achieve overall development by the adoption of high technologies. Okay, that is what Sarabhai's view was, and he had a very, very solid faith in space technology, and that is the mantra with which ISRO started. And even today, ISRO has progressed with this, and we have achieved a lot. I'm going to tell you about those things. First, India. Did India build a 15-story high rocket, the clipping of which I showed you? It could not. No child, no baby will walk once for all, and no Olympic sprinter will learn everything in one step. He or she is also a baby who tries to get up, falls, and all those things. Like that, India started its space program on a very small scale with the firing of sounding rockets. What are sounding rockets? Are they satellite launching rockets? No. They are small research rockets which are used for studying the upper atmosphere and the magma mainly. Okay, they are very small rockets. Sounding rockets are very small. And we have an advantage in India that the geomagnetic equator passes through the southern part of India in Kerala. Okay, Earth has a magnetic field, you know that. And like geographical equator, we have geomagnetic equator. Since it passes through the southern India, we have the advantage of studying many phenomena associated with Earth's magnetic field and atmosphere. Sarabhai said, we have this and we will offer to the international community, let there be a UN-sponsored rocket research station here. United Nations provided it. And that is how Indian space program started and got benefited through international cooperation. Look at that. This is the way in which rockets were being carried, not entire rockets. This is part of a rocket. This is the neck and head of a rocket. Okay, we say that this is the heat shield of a small sounding rocket which was being carried on the bicycle carrier. Those were the romantic days. Okay, this is where we started. And here you see two people. The person who is in the left, okay, his name is Mr. Aravamudan. Okay, and this is another gentleman who is there sitting with him. Both of them are struggling with a sounding rocket and putting some instrument into it. You see, he is wearing a banyan like this. Why? In Kerala, outside Trivandrum, it was so hot in those days. Okay, and you know, the thing is, there was no air conditioning system. By the time I joined, everything was there. You see, look at that, the sacrifice of those people in those days, the people who joined the Indian space program of 60s. Many of them who joined, they were from different parts of India, and many were vegetarians. In those days, vegetarian food was not easily available outside Trivandrum. Okay, not easily available. I'm not telling that it was not available. It was not easily available. So many of them, they carried food. They ate in the railway canteen, carried the food, and without any AC, without any cars or vans or anything, they started with bicycles. Okay, that is the way it was. And the name of this gentleman is Mr. Aravamudan, a confirmed vegetarian. And look at that. He is also, excuse me. Look at this gentleman. He is also a confirmed vegetarian. Look at that. He has not eaten properly. For you know, his waist tells that. Okay. His name is APJ Abdul Kalam. Yes, Dr. APJ Abdul Kalam, who later became the president of India. Okay, so he started his career almost just except for a short while where he worked in ADE. He space and Abdul Kalam sir was the project director of India's first satellite launch vehicle, SLV-3. What I would like to emphasize here is the sacrifice of the people in those days. That is what we have to understand. And all of you are listening to this, at least a small time in a day, okay, or in a week, you keep it for the country as such. A small part of your whatever resources you have. Everybody cannot become Mahatma Gandhi. You can be Lakshmi Narayana, you can be Guruprasad, but still do something for the society and do for the country. We can do that. Only a very little thing I am telling. That is the thing. So, of course, in 1969, Indian Space Research Organization came into picture. ISRO was formed in 1969. And in 1971, Dr. Vikram Sarabhai, who was the father of the Indian space program, suddenly died. What will happen to the Indian space program? Many people were thinking. But fortunately, the government chose the right person. His name was Professor Satish Dhawan, okay, whose centenary we celebrated last year. Okay, so that's the way it is. And Professor Dhawan, when he assumed the leadership of the Indian space program, it was a very critical time, and he provided a framework. He provided a form to the Indian space program, and he took many important decisions which later catapulted India into a prominent spacefaring nation. Professor Dhawan was the leader of ISRO, that is chairman of ISRO, from 1972 to 1984. And during his time, a lot of experiments were done. Excuse me. And it was during Professor Dhawan's time, India's first satellite, Aryabhatta, was launched from the former Soviet Union. But though it was launched from the former Soviet Union, but it was built in India, that too in Bangalore, in the industrial sheds of Bangalore, in fact. See, building an artificial satellite is not like building a motor car kind of thing, or a scooter, not like that, because a satellite has to work in space, which has an ambience, okay? The atmosphere, not the atmosphere, I would say the ambience means the surroundings are totally alien to us. In space, there is no air. There is plenty of harmful radiations. Temperature extremes are too much. How are you going to design a satellite and build it so that it survives for years together? Once you launch a satellite, you cannot go and repair it in space. You may be able to do it, but it would be terribly costly and challenging. But anyway, in less than 3 years, Aryabhatta was built and launched in 1975. And this was the gentleman who is the father of Vikram Sarabhai is the father of the Indian space program. Undoubtedly, this gentleman, Professor U.R. Rao, Udupi Ramchandra Rao, okay, can be referred to as the father of the Indian satellite program. That is why the satellite center, of which he was the first director, has been named after him today in his honor. Look at that. In the 1970s, when there was the experimental era of the Indian space program, we were still learning to build satellites. Look at that, the way in which a satellite was carried in a bullock cart and was tested. This is not a joke, okay? For conducting a particular test in those days, I'm talking about in 1977 or so, it had to be carried outside like this. But today we have facilities. If you take all the components of a satellite and integrate them, you can integrate them, test them, and take directly to the launch center. Under a single roof, we have got every facility today. Okay. Now, Aryabhatta, when we launched, Aryabhatta of 358 kilograms, 358 kilograms. Today we have a satellite. This is called GSAT-11. It has a weight of 5,800 kilograms. 5,800 kilograms, more than 15 times almost. And the thing is, Aryabhatta.
Sorry,
Aryabhatta.
sorry to interrupt. Somebody else is MD Nazir. He is also giving the presentation, and
Oh.
request him to. And like the option is open, therefore your screen is not visible. Sorry.
Oh my goodness. How? I think the system administrator has to take into account this one.
Yes, sir. Yeah.
Has that presentation done?
I think now he has stopped. I think now you can continue.
Yeah. Kindly, you see, the thing is, okay, anyway, let us not waste time on that. Okay, what you are seeing is GSAT-11 satellite weighing almost 6,000 kilograms. Aryabhatta satellite could able to generate an electrical power of only 47 watts. You know how much electric power this satellite is generating? Nearly 14 kilowatts, 14,000 watts. This shows how far we have come from the days of Aryabhatta. We have built in India more than 100 satellites, different types of satellites, communication satellites, weather satellites, okay, Earth observation satellites, navigation satellites, scientific satellites, robotic spacecraft, so many things we have built after Aryabhatta. Look at now, okay, we have the capability to build satellites, but what is their use? Why do we need satellites, first of all? I'll give you just one example. Whenever you go to an ATM, probably you may not be knowing that there is an antenna on its top. Yeah, now when you go next time, you have a look at it. On top of each ATM, you have an antenna, a small antenna that is talking to the satellite directly. One satellite or the other of ours directly. And imagine if our satellites are not there, what will happen to our ATMs, which are all connected through satellites, in fact. Today, satellites are our economic backbone. Okay, they are part and parcel, an integral part of our economic infrastructure. If satellites are not there, imagine what will happen. Similarly, on top of your house, even on top of my house, I have got Tata Sky, here Airtel is shown. Like that, so many things are there. And an antenna which is hardly 1.5 feet in diameter. Okay, that is the thing which is directly receiving hundreds of channels from a satellite. If the satellites were not to be there, what about your entertainment? You think of it. So we have satellites which are capable of doing all these things. They are communication satellites. Look at that. This is a picture of a slum in Mumbai I took. See, these kind of slums may not have many basic facilities, but they have satellite antennas. That shows how the satellites are influencing the life of the common man today. Okay, this is what I want to emphasize. And the thing is, not only for entertainment, even in the field of education and medicine, satellites are playing a very important role. For example, teleeducation. Most of the pupils, that is students, are in actually they are in rural areas, but good teachers are in urban areas. Instead of displacing them, you can establish connectivity between the two using satellites. Similarly, sorry about this. Similarly, you can actually establish connectivity between a doctor, a specialist doctor, as well as a rural patient using satellites. You need not displace them. Next thing is weather forecasting. See, once upon a time, if a cyclone, once upon a time, when a cyclone were to come, okay, tens of thousands of, when a cyclone affected India, rather it came and hit the coastal area of India, tens of thousands of people got killed in the 1970s and to a certain extent 80s. But look at that. Today, maybe a handful of people may be affected and killed, and loss of property is also minimized thanks to satellites, because they are giving a warning of the formation of a cyclone, the speed with which it is moving, the direction in which it is moving, when it is going to hit a particular area, all can be estimated with the help of. So this is what, this has been going on in India for the past 30 years. Many of us don't. Another benefit from satellites. Similar of satellites, I told you, during these COVID times, also November 7th, I showed you the clipping of a satellite getting separated from observation sensing satellite. What is a remote sensing satellite? A remote sensing satellite is an artificial satellite which is equipped with cameras capable of taking crystal clear pictures of the Earth's surface. Okay, look at that. This is southern India. Look at that. Okay, and this is Dhanushkoti here. Okay, Rameshwaram and Dhanushkoti here, and this is Sri Lanka. This is the Pak Strait, and you will marvel at this picture. Ah, so nice. That's all we can say. Picture looks good, but a trained geologist can identify many other things. For crops are here. Is there any groundwater? What is the potential of finding groundwater in this area? That is the second thing. Are there any minerals? What is the quality of the soil? Okay, how much of crop is there? What is the acreage? Is there any disease which is affecting these crops? All these things can be found out by scientists specializing in different disciplines. Satellite pictures. A satellite repeatedly passes over a particular area at free of cost, in the sense you need not have to spend any fuel on that. Okay, that's the thing. So this is another field in which India has done a lot of work in this, and India is a front runner and a pioneer of this type of satellites. I told you, what is the acreage of a crop? What is the yield of a crop? Is there any disease for the crop? Okay, all these things can be known. Our forests, how much of forest area is there? What type of forest? It can be discerned. And third thing is, if there is a desert, if there is desertification, why desertification has happened? You can see these things. And groundwater is another thing. You know, the thing is, before satellites came into picture, chances of finding groundwater were not easy. Now it has improved significantly. And so is the fisheries. Okay, this is another thing. And the art of map making, called cartography, it has, by leaps and bounds, it has been enhanced. Our capability in this has been enhanced thanks to satellites. And now we have our own navigation satellite system called NAVIC, or IRNSS, Indian Regional Navigation Satellite System. Many of us know what is GPS. GPS receivers are there. Even in my mobile it is there. But similar to GPS, we have our own navigation satellite system. Don't call it as Indian GPS, because our system is not global. It is in and NAVIX, and it is very, very good. But only in and around India, it works. We are content with India and our region, our country and our region. We are not reaching to the globe as of now. So look at that. All the 8 satellites, navigation satellites in this field, okay, in this system, were built in India and were launched by India and are being maintained very carefully from India. Using these satellites, if you are traveling in a lorry, or if you are traveling in a boat, or if you are traveling in our own, anywhere in India, in a plane, you can know your position, your speed, your direction very, 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 very accurately. Not only that, your time also you can know very accurately. And okay, the thing is, communications, TV broadcasting, okay, tele-education, telemedicine, weather forecasting, resource survey, okay, navigation, all these things are related to making the life of a human being, life of our citizens, more interesting, more safe. Okay, but what about the human quest for knowledge? From time immemorial, humans by nature, they are inquisitive. Okay, what is there beyond this mountain? Some of the humans might have wondered thousands of years back. Somebody asked Edmund Hillary, it seems, why did you climb Mount Everest? He simply told, because it is there. Like that, to understand our world, and to understand the sky, and to understand the happenings in the sky, to understand the sun, the moon, the other heavenly bodies, okay, planets, comets, asteroids, okay, stars, okay, galaxy, universe as such. Okay, the thing is, humans are interested in this. By nature, they have an exploratory urge. They are inquisitive. But if you look at the heavenly bodies from the surface of the earth, you can see them through visible light, or if they emit visible light, you can know about their presence. Or to a certain extent, radio waves also, if they emit, you can know. Right, to a certain extent. But the X-rays, the gamma rays, the ultraviolet rays, for the most part, okay, emitted by celestial bodies or heavenly bodies, they don't reach the surface of the earth. If they reach, all of us would have been killed. Okay, those dangerous radiations, they are not reaching the surface of the earth. From the point of view of human life or the life as such on the surface of the earth, it is okay. But if you want to understand the universe entirely, okay, all the aspects of the universe, it is a hindrance, because those radiations are not reaching the surface of the earth. What you do, if they are not reaching the surface of the earth, you take the satellites beyond the earth's atmosphere and put them in study. That is, India today has got one of the finest scientific satellite called AstroSat, astronomical satellite, which is a very capable one. You can see some of my former colleagues in ISRO, they look like surgeons in an operation theater, because that satellite had to be built in an ultra clean environment. We have all the facilities in India today. And the thing is, whatever goes up must come down. There is a saying. But once you launch a satellite into space, there is no guarantee that it will come down. If it is very near to Earth, it may come down, let us say, in about a few years. Very near means within a few hundred kilometers from the surface of the Earth, means they come down. If they are beyond 1,000 kilometers, maybe after several decades may come down. But satellites circling the Earth beyond that height, they will never come back. My dear friends, I would like to tell you one thing. It is as difficult to come back from space as it is to go there. Climbing a mountain is difficult. Coming down is relatively easy. It is not like that in space. It is as difficult to come back from space as it is to go there, I said, reach there. So, because when you are circling the Earth, you are traveling at thousands of kilometers per hour in space. And when you dive back into the atmosphere, you have to exchange that speed into something else, which is heat. Okay. So you have to have materials capable of withstanding the heat of the atmosphere. Then only you can launch human beings into space and bring them back safely. And 2 times we have already launched. This is one called Space Capsule Recovery Experiment in 2007. And India has launched in 2014 also a bigger capsule. This is the way in which our Gaganyaan capsule looks. And India has done a lot of experiments in this regard. And very few countries have done these kind of things. And of course, India has launched 3 satellites or 3 robotic spacecraft towards the other members of the solar system. 2 of them are towards the moon and 1 is towards Mars. I'm going to tell you about that. See, this is Chandrayaan-1, India's first mission beyond the Earth orbit. This was launched towards the moon in 2008, October 22nd. But you look at this spacecraft, my former colleagues are actually, they're all struggling to perfect this spacecraft for launch. This is in Sriharikota, our launch center. Before it was mated with the rocket, this is the way. And this is Chandrayaan-1 spacecraft, which was launched by PSLV in 2008. This is the way the mission of Chandrayaan-1 is. And look at that. Actually, when we launched it towards the moon, many people asked, what do we do with this kind of spacecraft? Already 12 people have walked on the moon and they have come back. They have brought 382 kilograms of soil and rock samples. What this Indian Chandrayaan will do? But look at that, what this is. This is a newspaper from Britain, not from India. It says, India's first lunar mission finds water on the moon, it says. That means before Chandrayaan was launched and went to the moon and started circling the moon, okay? If you were to ask a scientist who specialized in the moon, okay, is there water on the moon? he would have scratched his head and said, perhaps. But after Chandrayaan 1, if you ask the same question to him, now he says, definitely. Who is responsible for this? It is your own Chandrayaan 1. That's why don't think that what India can do. India can do wonders. It has done already, and it is for students to get inspired by that and work for our country as such. And after the success of Chandrayaan 1, we launched Chandrayaan 2 in 2019. Chandrayaan 1 went to moon. A part of that started circling the moon, and one TV-sized object went and hit the surface of the moon. We wanted to reach the surface of the moon at a place and time which we wanted. We proved that. After that, with the intention of landing on the surface of the moon like a helicopter slowly, and we sent a robotic car. We wanted to send a robotic car to the surface of the moon. With all this, we launched Chandrayaan 2019. Okay, 2019 we launched it in September. Okay, but the one which is this part of Chandrayaan 2, which is circling the moon, is working perfectly. Even today, it is working perfectly, and it is circling the moon at a height of 100 kilometers from the surface of the moon, not the earth. Okay, many people have forgotten. But the attempt to land on the surface of the moon like a helicopter, till the end it went okay. But in the final stages, due to a problem, technical problem, we could not accomplish this. We need not be disheartened. Today or tomorrow, we are going to do it again. Such setbacks, temporary setbacks, have come to the Indian space program earlier, and we never got disheartened. You should never get disheartened as far as space is concerned. It is inherently dangerous, challenging. But India has accepted the challenges and proceeded forward. Okay. After the moon, after the success of the moon, Chandrayaan 1 in 2013, India launched Mangalyaan or Mars Orbiter mission. What was the intention? To take a spacecraft, to launch a spacecraft, to build a spacecraft, to launch a spacecraft towards Mars, navigate it all the way to Mars for months together, make it to enter into an orbit around Mars, and survive there for 6 months. India wanted to prove, yes, we have the technology to do these things. So, our pride of India, PSLV, launched Mangalyaan spacecraft. This is the one. ISRO doesn't call it as Mangalyaan. Mars Orbiter mission. We call it a Mars Orbiter spacecraft, but they as Mangalyaan. So, this spacecraft was launched by PSLV on November 5th, 2010 months. It navigated all the way to Mars. Okay, halfway through the sun, halfway it traveled around the sun and went to Mars. Mars orbit the sun beyond the orbit of the earth. You know that. Next planet to us, as far as sun is concerned. So 10 months it took to navigate it all the way to Mars. And on September 24, 2000, this is the launch of Mars Orbiter mission spacecraft by PSLV. In the afternoon at around 2:48 or something, I still remember having attended that launch. And on September 24th, 2014, September 24th, 2014, India became the first country to, excuse me, I understand that there is some problem with just a moment, please.
Yeah, your PPT is not visible, but your face is visible. There you have to change that tab, the pinning.
Resume, yeah, resume presenting. Yes, that is what.
Yeah.
Yeah.
Yes, see now.
Yeah. Okay. Now, just a moment. Just a moment. Now it is coming.
Yeah, now it is there here. You see there in the Facebook also. Loading. Okay, loading means it will come there.
Okay.
Okay. Yeah.
Okay. On September
Yeah,
24th, yeah. On September 24th, excuse me, on September 24th, 2004, its speed was reduced intentionally using a rocket engine in the reverse direction, and it successfully entered into an orbit around Mars. India became the first Asian country to reach Mars, that is, to reach the orbit of Mars. And this is the way it achieved something which many countries, not even Japan, had achieved. Okay, you can see our Honorable Prime Minister Narendra Modi ji addressing all of us at that time, and it was electrifying. I still remember, I became so excited by his presence on that day, and we had achieved the unthinkable. Okay, in the first attempt, nobody will be able to do these kind of things very easily, but India had done that. We had not launched any mission towards Mars earlier. Okay, that is where the significance of achievement comes. Then in the next 6 months, in the sense, September 24, 2014, our Mangalyaan spacecraft actually started circling Mars. According to our requirement, if it were to work for 6 months in the orbit of Mars, it was okay. So March 24th, 2015, if it were to be working, it would have been okay for us, and all the objectives of the mission would have been realized. But my dear friends, please believe me, even today it is working. Forget about 6 months. Even after 6 years almost, it is working. You see what India is capable of. If we work together, what we can achieve. Let me tell you. So this is the significance of it. NASA has explored Mars excellently, no doubt about it. There have dozens of missions they have launched. Okay, Soviet Union and Russia have also done. They have not been very successful. Europe has been successful. But everybody, all these countries and continents, when they launched a spacecraft towards Mars, in their first attempt, they never scored 100% success. NASA did not score 100% success as far as its first Mars mission was concerned. India is the only country which has done. Should be proud of this one. Then in 2016 November, look at that. This is the cover page of the National Geographic magazine. You know how respected National Geographic is around the world. When I was in ISRO, they sent us a letter to the public relations wing. Sir, please, why don't you provide us a picture of Mars globe taken by your spacecraft? We will give credit. We want to publish it in our magazine. They said. On behalf of ISRO, we sent it. But when I looked at the picture in the cover page of the magazine, when I held it in my hand, I have told this many times to many people, tears started rolling down from my eyes. Who would have thought at the time of launching Aryabhata that we are capable of doing this? Look at that. Such a prestigious magazine has printed the picture of Mars taken by our spacecraft. You go and get this magazine in some library, it is available. Look at that. They say, courtesy Indian Space Research Organizations have told. What else you want as far as India is concerned? So now, as I told you, in all these slides, I told you about the satellites and the robotic spacecraft and what are the achievements in satellites as well as the utility aspect of the space satellites as to what they are used for and how significant their contribution is to our national economy and to our national security. But one thing, let me tell you, if you have the capability to build satellites, to test them and to manage them and to utilize them, it is not sufficient unless you have the capability to launch them. The only device today, the only vehicle today, the only technology today which is capable of putting satellites into orbit is the rocket technology. Remember, we started our rocket program, space program itself through sounding rockets. And I told you, sounding rockets are not capable of launching satellites. But anyway, we learned the ABCD of rocketry using sounding rockets. Let me tell you one thing. Let me say what India has done, all these things I've told you. Launching a satellite, my dear friends, is not easy. Okay, for the sake of understanding, let us say Earth is a perfect sphere, which is not the case. It is an oblate spheroid. And on top of that, there is no building except for a mountain, which is 200 kilometers high, let us say. Okay. Then on top of that mountain, you have a big cannon. Okay. A big gun. From that, you're going to fire a shell. Okay. A shell with a velocity, okay, speed with direction, a velocity of, let us say, 3 kilometers per second. Remember, 3 kilometers per second, not hour. So then what happens? As per the Newton's first law of motion, what does it say? Everybody continues to be in the state of rest or of uniform motion along a straight line unless acted upon by an external force to change that state. So if there were not to be any force which is acting on that shell, it would have traveled in a straight line as per the law of inertia. But unfortunately, that is not the case. There is a force which is acting towards the center of the Earth. It is continuously pulling it with an acceleration. Okay, that is the gravitational force. The net effect of the momentum provided, the net effect of the momentum provided by cannon and the gravitational force is the shell in a curved path, and it falls up, falls away here. Then you are angry. Okay, let me fire it with 5 kilometers per second. Instead of 3 kilometers per second, you will fire it with 5 kilometers per second. But this time, the curve is less pronounced and it travels up to here and still falls. Then you are so angry, you are going to fire a shell from this cannon at 8 kilometers per second. Then what happens? As it travels in a straight line, and of course it cannot, and as it travels in a curved path, the Earth's surface is also curving away at the same rate. It will always follow the curvature of the Earth and start circling the Earth. This is called orbit. Okay, it's a closed curve, orbit. So 8 kilometers per second is the velocity which you require to put a satellite into orbit. If you have more than that, okay, 11.2 kilometers per second, you can send it towards the moon or Mars or whatnot. That is the way it is. Now, India's first satellite launch vehicle, it provided 8 kilometers per second almost to the Rohini satellite carried by this rocket. This rocket is called SLV-3, Satellite Launch Vehicle 3. The project director of this, the leader of the team which built this rocket is none other than Dr. Abdul Kalam. Now, what is this 8 kilometers per second? Who knows, you may say. Look at that, the happy couple with the kid. So what is the speed with which they are moving? Average speed, let us say 30 kilometers per hour. Though they are very happy, 30 kilometers per hour, not second this time. 30 kilometers per hour. Okay, you don't like that. So you go to a bullet train. I'm standing in front of a bullet train in Japan. It travels at 300 kilometers per hour, 300 kilometers per hour. But there are still better bullet trains today at 500 kilometers per hour also they travel. Okay, then if you travel in a plane, jet plane like this, you can travel at 1000 kilometers per hour. 1000 kilometers per hour you can travel. Okay. Then if you travel in a supersonic airliner like this, it is not available today. I mean, it is not in service for passengers. But anyway, if you were to take it, you would have traveled at 2300 kilometers per hour. That was the maximum speed of that. And if you travel in this military plane of the United States, it's called SR-71, it travels at 3000 kilometers per hour. And if you travel in this space plane, it travels at 3500 kilometers per hour. It just goes to space and comes down. It doesn't orbit the Earth. 3500 kilometers per hour. So your TVS 50, 30 kilometers per hour, bullet train 500 kilometers per hour, jet plane 1000 kilometers per hour, that Concorde, that supersonic plane, 2,300 kilometers per hour. That black plane is 3,000 kilometers per hour. The space plane, 3,500 kilometers per hour. But my dear friends, what is the speed that is essential, minimum speed that is essential for a rocket to make a satellite to circle the Earth even at 200 kilometers? Do you know what it is? Like this, when the satellite separates from the rocket, last stage of the rocket, it is 28,000 kilometers per hour. Per second is equal to 28,000 kilometers per hour, which is 1,000 times the average speed with which we move on our roads in India. Can you imagine? That is why I said everybody cannot build a satellite carrying rocket. That too big satellites. So be proud of your country. And of course, India has got a spaceport called Sriharikota. You can see our PSLV again. I'm showing the pride of India. This is the one which launched our Chandrayaan, Mangalyaan, and recently after COVID 2 times it has launched. Once I told you, I showed a clipping 10 satellites, and the other one satellite it has launched. 52 times it has been launched, except for 2 times it has been almost continuously successful. Almost. That's the way it is. And this is GSLV. Still a bigger rocket, still in terms of efficiency, still better. And of course, GSLV Mark III. Okay, this is the rocket, the heaviest rocket, the most capable rocket built by India. Okay, the thing is, let me tell you, the weight of this rocket is 640,000 kilograms. And here, these 2 rockets which finding, I call them as Bakasuras. Okay, proverbial Bakasuras. In Mahabharata, you know, there was a demon by name Bakasura who used to eat voraciously, and he used to eat not only the foodstuff brought by somebody, he used to eat the person who brought them also, it seems. As Bakasura. Okay, 210,000 kilograms of propellant. Okay, 210,000. Let us. Okay. 420,000 almost. Okay, let us say 4 lakh kilograms of propellant. Propellant means fuel plus oxidizer. It consumes, these 2 rockets consume that much in 2 minutes, 2 to 2.5 minutes. What is this speed with which they gobble up the propellant? Okay, that is unimaginable. That's why I call them as Bakasuras. And now, the next great challenge for India is Gaganyaan. Till now, whatever programs we had, our satellite programs, our rocket programs, our robotic space program, everything is not crewed. CREWD, not crewed, unmanned, we used to say once upon a time. That word is not used. That is, we have not sent human beings to space. We have not launched human carrying spacecraft into space, but only satellites. Look at that. This is the one. Gaganyaan is a program of Indian space program, part of the Indian space program to launch human beings into space, make them to circle the Earth for 1 week and bring them back safely. That is the objective. This is the most challenging thing. And at the same time, other challenges are we have to build better rockets, more capable satellites, and we have to provide more services to other countries. And through that, we can establish our presence more at the global level and make profit for that. And of course, we have to take care of our country first and make our country stronger and more economically robust, using our space assets like satellites and rockets. So Gaganyaan is the most challenging program. So most of it I have told you about the achievements, but the challenges are now Gaganyaan, some more planetary spacecraft, more capable satellites, and more efficient and capable rockets. These are the challenges in front of us. But looking at our past experience and our past achievements, one can always be an optimist in this regard, provided, as I told you, the students have to study well as far as science is concerned, And you have to do mathematics well, not studying mathematics. Do mathematical sums well. Mathematics is the language of science. Okay, whatever you can do in 2 pages, explain in 2 pages, just by an equation you can do that. Okay, so I would request all the students to do mathematics well. Okay, study science well. Okay, basic fundamentals. You know, for example, in Gulbarga Science Center, you have many models and other things which you can see and understand the workings of scientific gadgets. Okay, that's the way it is. And as I told you, I would request you to keep a small part of your time, daily time or weekly time, for the country as such, and whatever resources you have, help others. Okay, in your own way, in a small way. Then if everybody were to do it in India, India would be a great country, greater than whatever it is today. That's all I would like to say. So Indian space program is the one which has made India more visible, and it has brought a lot of respect to the country. And that is why we have to be thankful to the Indian space program. And I'm very proud to say, place it on record to say that I am very proud to have worked for the Indian Space Research Organization 7 years, and I fondly cherish my memory of working there. Thank you very much. Now we can go for question and answer session, and now I will stop the presentation, and now you can ask me questions. Let me thank Mr. Lakshmi Narayana and all the people who have been responsible for making this, for organizing this program and arranging things very nicely. Thank you very much once again. Thanks a lot. Bye-bye.
Thank you, sir.
Yeah.
Now I request the participants, if you wanted to interact with Dr. Guruprasad, and if you want to ask any question related to the rocket launching and also satellites of India, you are welcome. One by one, what you can do is maybe in the chat box you can type your question so that a chance will be given to everybody. Hello? Hello?
So
Hello?
everybody is muted.
Hello?
Hello, sir. I think you. My voice is audible.
Yeah.
Thank you for the nice. Thank you, Dr. B.R. Guruprasad, for the nice presentation about our India's achievement, and being worked in ISRO. What is the future? What is your ambition for our country?
Sir, 1 minute. My link I will give here because that is not coming.
I thought you will tell about India's mission like Aditya L1.
Okay, I can tell you.
Can you please elaborate?
Yeah. The thing is, I thought I would say that, but the thing is, it should not consume too much of time. That's why I said. But specifically, you're asking a question on this. I'm telling you, Aditya L1. Okay, Aditya is the name of this spacecraft. Aditya is another name for Surya. Okay, that is a Sanskritic name. Okay, this Aditya spacecraft, okay, is a satellite which is being thought of and being designed and built for studying the sun continuously. But how can you study the sun continuously? When you are circling the earth, you will be sometimes on the day side of the earth, that is, sun is visible. Sometimes you are in the earth shadow. But how are you going to study the sun 24 hours a day means? Then you have to place the spacecraft in a particular place. Okay, that is why the spacecraft Aditya L1 spacecraft, L1 is the name of the place, okay, where Aditya spacecraft will be taken to a distance of 1.6 million kilometers from the earth towards the sun. Okay, from the earth towards the sun, it will be taken to a distance of 1.5 to 1.6 kilometers. It is a halo orbit around L1 Lagrangian point, they say. Let us not go to mathematics and all those things. From that spot, okay, The gravitational field of the Earth and the Sun will balance each other. Okay, so in some way the spacecraft will be stable in that place. Okay, and it will be able to see the sun for 24 hours a day, and it has got many instruments. One of them is coronagraph, we say. See, mainly it is intended for studying the corona of the sun. Okay, sun has got an inner atmosphere called chromosphere and the outer atmosphere called corona, and there is a continuous stream of particles from corona. It is called as solar wind. Excuse me. Sometimes there is a big volcanic explosion kind of thing, or let us say, okay, volcanic, which lot of particles and radiation which escape from the corona. It is called coronal mass ejection. Okay, when those particles come and hit the Earth's magnetosphere, there will be a lot of disturbance, and chances are that our power grids and the satellites and the International Space Station, all of them get affected. So if you can predict, like, for example, like predicting the cyclones, like that, if you can predict coronal mass ejections which are directed towards the Earth, then it would be very good to protect ourselves, the entire Earth. Okay, from that point of view, you have to study and understand the sun in depth. And this Aditya L1 is intended for that. Okay, that satellite will be built in India and it will be launched from India. And our chairman, ISRO chairman, has told that it will be launched sometime this year or early next year. That's the way it is. I hope I have answered your question. Hello? Mr. Ebenzir,
Yeah.
did I answer your question?
Yes, sir. You have answered my question. Thank you.
Thank you. Yeah. Any other question? Another challenging thing we have is Chandrayaan 3. In Chandrayaan 2, though we have been successful in placing the spacecraft into an orbit around the moon, again with a lot of instruments, we are studying the moon in an intense way. We were not able to land a spacecraft softly, that is like a helicopter on the surface of the moon, and that attempt will be made again through Chandrayaan 3. And similarly, there is another mission called Shukrayaan. Okay, that is a mission towards planet Venus. Also a very interesting planet, and it is in fact the nearest planet to Earth. But alas, there is a lot of difference between Earth and Venus. But to study and to understand Venus, this start off, that is Chandrayaan 3, Shukrayaan, Gaganyaan. These are the main things which are there. And apart from that, I told you to build better satellites, more efficient satellites, more efficient and capable rockets. I told you. That's. Any other question?
Hello, sir. One question from me.
Yeah, tell me.
What advantage of any launching station which are very near to this geo?
Near to? I didn't hear your question. Again, you are muted. Mr. Lakshmi Narayana, kindly unmute your mic and ask the question again. Hello? Hello? You have to unmute. Hello? Hello?
It is so unfortunate. His internet is a bit unstable. He went out and He's coming back.
Yeah. Yeah. He's asking through mobile, I think.
Problem was there. That's
Yeah.
why once again I reconnected it. Okay.
Yeah.
Okay.
Tell me.
Yeah, I am asking question in the mobile now.
Yeah. Ask me.
What is the advantage of having? Oh, ಎಲ್ಲ ಕಡೆ sound ಬರ್ತಾ ಇದೆ. What is the
ಪರವಾಗಿಲ್ಲ ಹೇಳಿ.
advantage of having satellite launch stations near the geomagnetic equators?
Okay, very good. Okay. Not satellite launching station, for studying in the
That rocket launching station actually. Rocket launching station only.
Okay. I understood. Tumba
Yeah.
Equatorial Rocket Launching Station. Yes, very good question.
Yes.
Yeah. See, the thing is, near the geomagnetic equator, you can study many phenomena. Okay. Like, for example, there is a thing called equatorial electrojet. Okay, that one. And near the geomagnetic equator, the magnetic dip will be 0. Okay, the settles in a particular way. That is the area where you can study many phenomena associated with the Earth's magnetic field as well as the upper atmosphere in a better way. That too from India. That is the advantage we had, and that's why United Nations also came forward, and that's how Tumba Equatorial Rocket Launching Station was established, and the rest is history. So the genius of Sarabhai was not only in recognizing the potential of space, he made use of India's advantage, geographical advantage, in a particular way, and through international cooperation, he began the Indian space program. That is the best part. We need such people. Yes. We were fortunate to have such people. That is. Any other
Thank
question?
you, sir. Any other question, please? Chellasamy from he is there online, I think.
Hello.
Sir, I am online, but I finished asking question.
Okay, thank you.
There is one Suryakant Miskin who is asking something. Yes, Mr. Suryakant.
Mobile, He's the staff of this from his mobile. I asked a question.
Okay. Good. Okay. Okay, if there are no more questions, we'll call it a day. Otherwise, I'm ready. Okay.
If there are no questions, we will wait for only 1 or 2 minutes.
Hello.
Hello. Yeah, no questions. I think so, sir.
Fine, no problem.
Now, on behalf of the District Science Center Gulbarga and on behalf of me, I thank Dr. B.R. Guruprasad for having delivered the lecture, and he has shown a lot of videos also. It was convincing, and the information given was wonderful. I think who are there online and also who saw this program through maybe Facebook, there are several people. I think I have seen comments in the Facebook also. They were enjoying your talk and also the video which you have shown. And once again, I thank you on behalf of the Science Center and on behalf of me, and also on behalf of National Council of Science Museum, Ministry of Culture, Government of India.
Thank you very much. Nice to have been with you.
Yes, sir. Yeah, from NCSM face link, and there also many people have seen, and it was a wonderful session. Thank you very much once again.
Thank you. Bye.
Yeah. Shall we exit now?
Yeah.
Yeah. Thank you, sir. I will call from the mobile.